Okay, we're gonna make a quick video on the law of sines because I know this is something that's been frustrating a handful of students. So let's just go ahead and see what the problems look like. Okay, so now we need a way to figure these out. So let's just solve this problem here. We don't have let's say we don't know law of sines yet. So we're just going to see how can we figure this out on our own and see if maybe we can come up with a shortcut, and that shortcut's going to be what we call the law of sines. Okay, so we have a triangle over here. It doesn't matter how good our picture is. 7 and 10 to 23 degrees. And it's going to want us to find this angle right here. Let's make sure that's true. Yep, this is C. The one between 10 and 7 is B, and the 23-degree angle is A. Okay, so it wants us to find this. Well, I'm going to try this. Right? If I cut this like this, I get a right triangle. Right? So we know this 10, we know this 23, and we're looking for the height of the triangle. Let's just call it H. Right? Well, the H is on the opposite side. So that's going to be the sine of 23, and that's going to equal the opposite, which in this case is H, over 10. Opposite over hypotenuse. Multiply both sides by 10. Right? So I now know the height. Well, now look at this other one, right? The sine of angle C, right, is going to equal the opposite. Well, we know what the opposite is now. It's this right here. 10 times the sine of 23. Let's just call it H, though, because we're lazy. And that's going to be over 7, right? Because 7 is my hypotenuse. And multiply both sides by 7. Both sides by 7. And here's where it gets interesting. This equals H, and this equals H. This would have worked no matter what these numbers were, right? If we instead had just said A instead of 23, this would be A. If this was little c instead of 10, this would be little c instead of 10. So really, let's actually do this again, but let's get rid of all of the numbers and just use letters and see what happens. Okay? Oh, crap. I accidentally clicked on something else. Okay, don't worry, it'll give me back the same problem, so it doesn't really matter. Let's go. Okay. So instead, let's get rid of everything that we knew previously. Give me just 1 second.
I get it. Thank you.
Okay.
W1.
So let's call these. Let's give these things names so that we can see what they're called. All right. Let's call this one A, and then B, and this one C, and then across from it we'll call this little a, and across from big B we'll call this little b, and across from big C we'll call this little c. Okay? We're going to set this up the same way. We're going to assume that we're going to relate A and C to each other again. Okay? We could have flipped this and instead related A and B, or B and C. It doesn't really matter which ones we relate. This is just for any triangle, any two random angles, and the sides across from them. Right? So notice, right? I'm going to call this H again. Notice that the sine of A equals H over C. If we multiply both sides by C, we get C times the sine of A equals H. We're going to do the exact same thing over here, right? The sine of big C equals H, the height of my triangle, over A, my hypotenuse. Multiply both sides by A. This cancels. These are both equal to H. Okay? I'm going to scroll over so I have a little bit more room. Oh, what do I want to do here? Oh, no, we'll scroll down a little bit. Okay. That means that C sine of A equals A sine of C, where this is big C and this is big A and this is little a and little c. Okay? Now, if I divide both sides by CA, here the A's cancel. Divide this by CA, here the C's cancel. And we get the sine of A over little a equals the sine of C over little c. Now, first off, we were able to solve this problem without knowing the law of sines. This right here, this is the law of sines. Okay? Which means now we can just plug stuff in instead of actually doing anything. Right? So let's copy this for a second. I don't think I can just click on it and move it, which is lame. Okay, so we'll just write it up here. Alright, so we know the sine of an angle divided by the side across from it equals the sine of any other angle of that triangle divided by the side across from it. So the one we have the sine of 23 divided by 7 equals the sine of, in this case, C, big C, divided by the side across from it, which is 10. Multiply both sides by 10. Right? So the sine of big C equals 10 times the sine of 23 over 7. How are we going to get rid of this sine? Well, remember, sine, like most things, it takes an angle and it turns it into a ratio, right? Opposite over hypotenuse. Well, we will know a ratio, right? And we want to know the angle. That's sine inverse, right? This one goes the other way, right? It takes the ratio and turns it back into the angle. So we're just going to do sine inverse of this giant mess, right? 10 times the sine of 23 over 7, right? And that's going to give us our angle. Okay, if you're using a PC, you can use this calculator. If you're using a device, I've been told that the calculator doesn't show up in Khan Academy. So use whatever calculator you want to, times the sine of 23. Notice I'm in degrees. That's really, really important. Divided by 7. Right, and that's going to give me my mystery angle here. 33.93. It wants me to round to the nearest degree, so it's going to be 34. Okay, and it liked that answer. Okay, round to the nearest tenth. We're going to be looking for AC right here, and then we're going to round our answer to the nearest tenth. Well, we already have a strategy for this now. Zoom. Give ourselves the most amount of room as we can get. Not like we actually need it, but whatever. Okay. We're going to set this up the same way we did before. So first, we're noticing we have a sine of 23, right? And that's going to be divided by the side across from it, which is 7. And that's going to equal the sine of 71 and whatever the side across from it. We're just going to call that x. Okay. Now the thing here that's kind of interesting to note that I want you to see. Notice that notice this is 23 degrees. Notice this is 71. The biggest side is always across from the biggest angle. 71 is bigger than 23. We expect x to be bigger than 7. If x is not bigger than 7, then I've made a mistake. So let's get x by itself. Okay, I'm going to multiply both sides by x so that it's not in the bottom of a fraction. Okay, and now I'm going to multiply both sides by 7 to get rid of the 7. Then I'm going to divide both sides by the sine of 23 to get rid of the sine of 23 on that side. Now we have the x all alone. Let's rewrite that so we can see it. X equals 7 times the sine of 71 divided by the sine of 23. Okay? And we're going to do the same thing we did last time. Just dump this 7 times sine, dump it directly into the calculator. 7 times sine of 71 divided by the sine of 23. Okay? Notice I'm in degrees. Always check to make sure you're in degrees. 16.9, and if we round to the nearest tenth, it's still going to be 16.9. Right, 16.9. Check. We managed to get that one correct. Let's do a new page. Oh, you know what? We don't need to do a new page. Oh, we already did. Options, 200%, whatever. Okay, and we'll scroll this up closer to the top. Okay, and let's do that over here too. And then that way, if we do our next problem, we can just slide a little bit. Okay, measurement of angle A, right? What is this angle? Well, we're going to use the law of sines again, the little trick, the shortcut that we came up with, right? We're going to do the, let's change the color just so things feel different. Let's go a little darker. Okay. Okay, so we have the sine. The angle we do know is 25. That's going to be divided by the side across from it, which in this case is 5. And that's going to equal the sine of A, right? Because the angle A is across from 11. So that's why we're picking sine of A. So now we're going to multiply both, and it's also because it's what they're asking for. We're going to multiply both sides by 11. So we get 11 times the sine of 25 over 5 equals the sine of A. Just like before, we're going to do the inverse sine so that we can take the ratio, right? Sine of A is the opposite over the hypotenuse. If we do the inverse sine of sine of A, that'll give us back the angle, which in this case is A. So, all right, inverse sine undoes sine. A is going to equal sine inverse of 11 times the sine of 25 over 5. Now remember what I said before, right? 11 is bigger than 5. We're expecting the angle here to be bigger than 25 degrees. Let's see what happens. Sine of inverse, right? 11 times the sine of 25 divided by 5. Okay? And we get 68.39, round to the nearest degree, so it says 68. Check on that, and that worked fine. Next question. Scroll just over this way so we don't have to make a new page. Okay, so we know 2 of our angles, but we're missing a side. We're missing AC, right? We don't know the length of the side across from here. All right, so let's set this up. What we do know is we know, okay, it's getting wonky on me. Okay, so the sine, yeah, I don't know why I was doing that. Okay, so the sine of 20, okay, that's just terrible. Okay, the sine of 23 over 6 is going to equal the sine of 132 over our unknown side. We're going to do what we did the other time we had a problem like this. Multiply both sides by x. So x cancels, multiply both sides by 6. The 6's cancel on that side. Divide both sides by sine of 23. So that cancels. Divide both sides by the sine of 23. So that cancels. So we're left with x equals 6 times the sine of 132 over 23. Now notice something. 23 is across from 6. Our unknown side is across from 132. We're expecting whatever the side that we don't know it is, it should definitely be a lot bigger than 6. Right? Maybe twice the size. Maybe, I don't think it'll be 3 times the size. Let's see. So we can just enter this in directly as it is. 6 times, make sure I'm in degrees, sine 132 divided by 20. Oh, look at that. Almost made a mistake. I'm dividing by the sine of 23, not by 23. Okay, the sine of 23. Let's change how I wrote that over here so we can see that this is really supposed to be the sine of 23. Okay? Go ahead and hit equals. And we're getting 11. Not quite double. It wants us to round to the nearest 10. 11.4. Okay, check, and it likes my answer. Okay, that's solving triangles using the law of sines.